here. That might help a little bit. We're going to find the slope of each equation. So remembering that we talked about earlier that the slope is whatever precedes the x immediately. I see a negative 2 in front of a, so the slope is negative 2. In b, there are no x's. So what would be the thing that precedes? Like there's not even an x visible. Or in other words, it says plus 0x. So 0 is the slope. If you don't even see any x's, it's 0. What if you don't see any y values? Like over here in part C, there's nothing there. Good guess, because there would be a 1 in front of the x, but if there's no y's, there's actually, this is kind of a different situation. Undefined. This is one of those vertical lines. So if you were looking at a graph of x equals 4, it would look something like this. I'd have a graph, and my line would be a vertical line at x equals 4, which means the slope is undefined. Some teachers in the past, for that or for a horizontal line, have used the phrase no slope. Don't use that. This one's undefined. In part B, same kind of deal is going on, except the line would look like this. At y equals 5, it's a horizontal line. So B and C are very special lines. They only have one letter. If it's a y equals, it's horizontal. If it's a x equals, it's vertical. One has a 0 slope, that's the horizontal one. One has an undefined slope, that's the vertical one. So horizontal 0, vertical undefined. In letter D, if I were to distribute the 2 to each of the pieces, meaning I would take this 2 times the x and the 2 times the negative 4, I would see y equals 2x minus 8 and then plus 8. And then, of course, if I simplify, the 8's go away, so I have y equals 2x. The number immediately preceding the x is a 2, so my slope in this case is 2. In letter E, there's a lot of stuff going on. In order to find the slope, what you want to do is you want to get the y alone, meaning that there's no other terms with it, and there's a 1 in front of it. So the first thing that I'm going to do is I'm going to subtract off 5x. So I minus 5x from both sides. On the left, the reason that we're doing that is because the 5x's disappear. I end up with 3y. On the right side, the 12 and the 5x thing cannot go together because they're not like terms. So I have 12 minus 5x left over. And then I see that I have the y term alone, but there's a 3 in front of it. So I need to get rid of that 3. I divide every piece by 3 so that the y will have a 1 in front of it. So these 3's over here reduce and are gone, and it'll just be y equals something. And I'm looking for the thing immediately preceding the x. And I notice that the thing immediately preceding the x is this stuff. What that means is that my answer is going to be negative 5/3. That's what's directly in front of the x thing. There's a negative sign, a 5, and a 3. Negative 5/3. Yes, sir.
So you do nothing?
What's nasty about letter F? Fractions. A lot of fractions there. That's annoying. I don't know about you guys, but it's kind of messy to work with. So I like to use a strategy where I get rid of all fractions. Okay, that's where you multiply by the least common denominator. Notice how all the denominators are different? It's not a problem. The way that you take care of that is you look at the number that you would get when you multiply all the bottoms together. So 5 times 3 is 15. 15 times 4, 60. I multiply every fraction by 60. Every fraction. When I multiply every fraction by 60, 60, and if I look at the 3/5, 60 times 3/5 would be the same as 180 divided by 5. Or in other words, 36. You can check that out on your calculator if you want. 60 times 3 is 180. 180 divided by 5 is 36. Oh, don't forget about the y over there. So that's when I multiplied the 60 by this. Then I'm going to multiply the 60 by the 1/3 x. When I multiply the 60 by the 1/3 x, 60 times 1 is 60. 60 divided by 3, 20. Don't forget about the x. And then I'm going to multiply the 60 by the positive 3/4. So 60 times 3 again is 180. 180 divided by 4, 45. And what we see here is now an equation that has 0 fractions in it. So that's kind of a nice strategy so you don't have to deal with fractions. If I divide every single piece by the 36, which is the number that is in front of the y, what I'm going to find is the number immediately preceding the x. And I will have to simplify that, of course. But the number immediately preceding the x is this 2036 thing. So I take, on my calculator, 20 divided by 36. And then I simplify it by going math, enter, enter. So 20 divided by 36, math, enter, enter. How much? 5/9? Thank you. 5/9. In the word problem number 2, you'll notice that they give us a table. And in this table they have a lot of data points. And what you'll notice is that they talk about a couple of different things. The first thing that they talk about is the number of batteries. Usually, 95% of the time, maybe even more, whenever they give you a table, the first thing that they list, that's the independent variable, otherwise known as the x values. And if you're ever going to use your calculator, that means that you'll be putting these things, if we use our calculator, into list 1. And the second thing that they list, generally, 95% of the time at least, are the y values. And if we were using our calculator, we'd put them in list 2, and those are the dependent values. Does it always like that? No, but pretty much always like that. Now Leighton, he measured the voltage across different numbers of batteries placed end to end. And he recorded the data. So they tell us, they even tell us that X is the number of batteries. And then they tell us Y is the voltage. Like they even give it to us. And generally that's what's going to happen. We want to find the slope. So now in order to find the slope, we know that slope is the change in the Y divided by the change in the X. The cool thing is it doesn't matter which 2 points we pick. And if all of our answers aren't the same and we pick 2 points, you're still going to get it right. So this is a pain in the bottom to try and grade on a test, but it's the way it works. So Josh, which number of batteries do you want to look at? 4. So one of the situations that we're going to pick is we're going to choose the one that deals with 4 batteries. And we're also going to pick something different. And Kim, which one do you want to pick? 6. So we're going to pick these. Oh, that means mad. 6. So these are the 2 points that I'm going to talk about when I find the slope. If you were to pick 2 different points, it's fine. I'm picking those 2. Remember that when we're finding slope, our slope is y2 minus y1 over x2 minus x1. So pick the second point and then use the first point. For us, Kim picked a 6 one, so that was these set of information. And Josh picked the 4, so that was the first point of information. And I'm going to use that information in order to find my slope. So the second y value was 8.82 minus the first y value, 5.88. Again, this might not be the same if somebody chose different points, and that's okay. And we're going to divide that by the second x value, which was 6. Take away the first x value, which is 4. So respectively, again, the second values were these 2, and the first values were these 2. And now I just type that stuff into my calculator and go from there. By the way, just in case anybody forgot their calculator, I grabbed an extra one today in case you need to use one. Here you go. Got it up here. Feel free to come up and grab it.
You got to plug it in?
Yeah. Yeah, there's, really? Yeah, really. So I get 2.94 on the top. Somebody check my math, please. Yep. And then on the bottom, of course, I get 2. And so my slope is 1.47. And again, this slope is the slope that I got with the 2 points that I chose. It is possible that if you chose point 1 and 2 battery thing, that you could get a different slope. That's fine. Because when they give you a table, you can pick. Would all the students get the same answer for the slope? The answer is not necessarily. Oh my goodness. Because there might be different points that were chosen. The real world meaning of what the slope is talking about is saying for every 1 battery added, my volts increase 1.47. So every time I add another battery, my voltage goes up by 1.47. That's what it's saying. And then the last question is, does it make sense that my y-intercept in the line is 0, and then why not? The answer is yes, it makes sense, because if there are no batteries, then there is no voltage. So you can't really have any power going on if there aren't any batteries. So no batteries, no voltage.